Welcome back to another Vista tutorial. In this video, we will learn how to populate grass and detail objects on the terrains using several techniques, including grass cover, using ground texture, color, and noise, patches of flowers at random places, and broken branches and cones at the tree stump. We'll also cover how to use the template variance feature to populate multiple types of grass or detail object using a single output node. This will greatly simplify your graph while making your scene more natural. For this tutorial, I'll use these grass textures and detail prefabs. Please make sure that your prefabs have only one mesh renderer component, because terrain detail doesn't support LOD. To populate grass on your terrain, you need to create a detail density output node. Similar to tree output node, the detail density output node requires a detail template asset to be assigned. To create a detail template asset, right-click on the project window and select Create Vista Detail Template. In the inspector, the detail template allows you to select its property display mode. Here I will set it to Unity Terrain. I want to use a grass texture for this, so I will set render mode to grass, or you can use grass billboard if you like. Then I'll drop my grass texture here and leave other settings as default for now. Back to the graph editor, I'll drop my detail template into the slot. In the last video about texturing, we already had a variable storing our green texture mask. Now we will reuse it to spawn grass at the location where the ground texture is green. First, add a get variable node and select the variable grass mask. Connect it to a levels node in case we need to adjust the mask. Then plug it to the detail density output node. Save the graph and back to the scene view. You should see the ground is now covered with our grass. This is the most basic technique for the task. Let's say that I want to spawn another grass type that's pretty similar to this one using the same rule. I can create another detail template, copy the settings, then add another detail density output node. However, that approach is messy and time-consuming when you have many variants of the same grass type. A better approach is to use the variance feature. In the inspector, under the texture slot of your detail template asset, you can put your variant textures to this list. Then regenerate the graph. You can see that the variants start appearing somewhere on the terrain, but with visual artifacts. That's because the terrain has reached its limit of grass instance number. To fix this, select your terrain and lower the detail density value. Now, we will spawn another type of grass using noise. This time it will be a prefab. Create a new detailed template asset. Set your render mode to vertex lit and assign a prefab to the slot. I also set its width and height to a slightly bigger value. In the graph editor, add a noise node. I will use a scale value of 100 to adjust the remap curve, so I will have sharp noise pattern. But it's up to you. Adjust it to the look you want. You can see that with this mask, our grass will grow everywhere regardless of the scene geometry. We need to prevent it from growing on steep area. Once again, get the grass mask and multiply it with our noise. Finally, plug it to a detail density output node. Save the graph and back to the scene view. Here we are, our third type of grass. In the next example, we will spawn this heath detail prefab at random places. But instead of using noise map, their position are now from a position buffer. To do that, you need to add a splatter node. The splatter node allows you to scatter a mass texture using input position, somewhat similar to the texture bombing technique. I will change my preview mode so you can see it clearer in the 3D preview. The first input is positions. You can generate a random set of points using the points and spread node. The second input is mask, which is the mass texture that will be scattered. Here I generate one by multiplying a cone shape with noise map. The last three inputs, rotation, scale, and intensity, you can plug them to noise maps, but I will leave blank for simplicity. Lastly, multiply the splatter result with our grass mask to prevent them from growing on steep surface. Plug the result to the detail density output node, save and back to the scene view. Very nice. Now we have clumps of heath scattering around at random spots. The last thing we will do in this tutorial is to make some branches and pine cones falling around the tree stumps. Let me disable other grass types so you can see it clearer. For these branches and cones, we will use only one detailed template asset with many variants set up like this. In the last video about spawning trees, we already had the position of all trees in the scene. We will gather them into a single position buffer by using the append node, then assign it to a graph variable called tree positions. The idea is to draw one pixel into the detail mask at each tree location. To do that, add a dots node with its input comes from our tree positions variable. Each dot here is one pixel on our mask. Then you can make the mask smoother with smooth node. This node is a bit expensive to compute, so make sure you use a small iteration count. Use a levels node if you want to adjust the mask further, then plug it to a detail density output node. Save and back to the scene view. Good, we have some falling branches and cones. However, it's not good enough for my taste. I want to make them spread to a broader area. How to do that? Of course, we can increase the iteration count of our smooth node. But as I've just mentioned, that node is a bit expensive. We can get around this by selecting the dots node and lower its resolution multiplier. This will make it generate a mask with less pixels. Thus, each pixel will be bigger in world space. Save and back to the scene view. Excellent. Remember to enable other grass types in your graph to complete this task. And that's some technique you can use to add details to your terrains. See you in the next video.